Hello. To begin, I have a simple question for you. How many of you can say where your data goes when you query an AI system?
At Miranui, we ask ourselves a very simple question. Not a marketing one, but a real practical one. After seeing numerous AI architecture, we noticed a paradox. Sorry. We noticed a paradox. We wanted to answer, does artificial intelligence really need to live our world to be intelligent? That's the question. After seeing numerous AI architecture, we noticed a paradox. We saw that critical and sensitive information, like images, industrial signals, medical informations, are sent to distant cloud, sometime on another continent, just to train or run a model which then makes its decision here locally on site. In this process, we lose two essential things: control and consistency. Control because we don't know really where the model runs anymore, we don't know who has access to it, and we don't know how it evolves. Consistency because intelligence becomes disconnected from the real world, from the operation, the machines, from the field.
And beyond that, there is a larger context. Over the past 5 years, there has been a strong concentration of solutions among a few tech players. Think of the recent outages at AWS, Azure, and Cloudflare, which remind us that relying on single provider, no matter how good, can have major consequences in the event of failure. Moreover, geopolitical tensions are redefining the digital landscape. It's no longer taboo for some states to use this dependence as leverage. For example, consider the ICC judge who lost access to all US digital data. States want to regain control of their data, companies want to reduce their dependence to foreign providers, and public organizations need to ensure service continuity even during crisis. In this context, sovereignty is no longer just a political topic, it has become an operational one. That's the real problem today, too much dependence on external connectivity. Today, the resilience means being able to continue operating when the internet goes down, and this is where local, sovereign, and distributed architecture really makes sense. In the end, it's a simple chain. Sovereignty means taking back control. Control reduces dependencies. Fewer dependencies mean fewer points of failure, and fewer failure mean more resilience, and this is why sovereignty and resilience are connected. It's the same problem seen from two different angles.
So we ask ourselves, what if we could bring intelligence closer to the data itself? That's where Edge AI, but with a sovereign touch, comes in. Our goal was clear, to show that AI can be high-performing, modern, and entirely European without making your data leave this trusted environment.
And before we talk about how Edge AI is used, let's define it simply. Edge AI means running AI models directly on devices or infrastructure close to the data source, sensors, cameras, smartphones, or industrial systems. Instead of sending everything to a distant cloud, the intelligence stays near your data source. In practice, Edge AI is applied in two main ways. Edge in data room. This is when your critical AI models run on a local infrastructure inside your own building. Your data never leaves your building. And Edge on IoT, the AI model is embedded directly inside your industrial equipment, sensors, machine controllers. The AI reacts immediately without reaching for external connectivity.
So when we look at real project, edge computing the value of edge computing becomes very clear. On one side, when we execute models directly on edge, we can leverage real-time execution, have low latency, and data privacy improves because only sensitive data stays local, and processed results can go out if you want. On the other side, you can leverage the cloud for the model training, the versioning. So let's say you have the best of the two worlds with the edge computing. You can enjoy on-site, local executions and low reactivity, and you can use the cloud on its scalability to train models faster. And with edge, you don't have to choose between these two. You have to choose between these two.
Okay, and today several European vendors allow you to deploy AI models directly on premises, so your data never leaves your building. This approach is becoming the norm in sectors who manage sensitive and business critical information, and that can help you to eliminate leaks and reduce the dependence on providers, external providers. Several LLMs are designed to run on premises, from open weight models like Mistral to more sovereign grade solution like Aleph Alpha. They can run in your own servers or in a GPU machine from European providers like OVH Cloud, Yonos, Clever, and Clever Cloud or Scaleway, for example. On this industrial side, AI models can also run directly inside your machines.
We often talk in sovereignty about theoretical terms, but in practice, it makes real sense. You can, when intelligence stays close to the data on the ground, the benefits are immediate. Responsiveness, security, continuity. But when we talk about complete sovereign use cases with edge and AI, it's not totally the case to see, let's say, this at the moment, and we will give you 3 concrete use cases. For example, in industry, you can imagine a plant where you have control quality camera which can monitor in real time the production process. If, let's say, a defect is detected, an alert can be sent immediately. The production process can be stopped, and someone can take care of it almost immediately, without depending on network connectivity, without pushing sensitive data like images, and you can reduce production stops up to 40%. But if to train your model, you rely on distant cloud to push your data and make the training, you can offer this competitive advantage to your competitor. On mobility, you have buses, cars, trains which are using embedded model as well. This model analyze vehicle signals like brakes, speed, vibrations, and other stuff, and can prevent any harmful situation before they happen. This is what is provided by ADAS systems and other driving assistance systems. But if these models are trained and made by foreign actors, you lose control over their operation. So in this case, you have an edge model you don't manage really well.
And in healthcare, the sector follows the same logic. We saw a large French medical diagnostic company build a secure ChatGPT-like assistant for their teams, and the goal was to answer complex scientific questions using their own validated data, without sending anything to the external services. They run a POC to compare models, validate accuracy, and confirm that everything could operate in a controlled environment. They are built the secure GPT, but without thinking about the sovereignty and the overall architecture. So, because what? Because at the time there was no real alternative to do that. But now we have the choice. We can make architecture really sovereign and really secured.
So our demo, let's say what we've built an AI system, a complete AI lifecycle, which relies only on European technologies. On one side, we use Yonos Cloud for the model training, image collection, hourly retraining, core ML, and other AI stuff, which is after pushed to the edge device. On the edge device side, we use it to analyze, it's an object detection system, which analyzes video streams and does not push anything to the cloud. But if some detections are very precise, we push the metadata to the cloud to propose a retraining and to push a next version to the device. This is a complete AI lifecycle, fully sovereign on European, which proves that we can use these technologies to implement AI use cases without relying on foreign actors.
And to do that, nothing has been sacrificed, not performance, not scalability, not integration. Thank you. And come
to see us
to see us in our booth just behind.
Thank you very much.
Thank you.